All right, this is our second lecture on the integumentary system, or the skin. This time we're going to talk about the functions of the skin. So we'll talk about the role of the skin in temperature control and regulation, protection and sensation. We'll discuss skin cancer, burns, and aging of the skin, a little bit about acne, that kind of stuff. So let's get right into it. So every time we talk about an organ system, I'll give you a list of functions of that system. For the skin, that list begins with protection. The skin protects underlying layers. It protects against abrasion. It protects against damage from ultraviolet light that would normally damage DNA. The skin is a barrier to the entry of microorganisms. It's got this layer of dead cells that are constantly shed, that are difficult for any organism to infect or digest. And there's some antibacterial secretions of the skin. And the skin contains lots of immune cells. So the skin has a big role in preventing infection. The skin also prevents water loss. So it helps protect us against dehydration. In this chapter, they talk a little bit about the skin and sensation. Okay, the skin contains lots of our sensory cells that are involved in the general senses. These are the individual cells or cells with just a few additional kind of accessory cells that are relatively simple. They detect things like temperature, hot and cold, particularly touch, several types of touch receptors, light touch, deep touch, pressure, and then pain. Our pain receptors are located primarily in the skin. And so the skin is a large sense organ, and it's not all equal. Lots of these things are concentrated on our face, on our hands, and in a couple other places where we have these receptors. We'll talk more about sensation later, but the skin has lots of sensory organs, and lots of these are located at the base of hair follicles. Okay, then the one of the biggest things and kind of a homeostatic system is the skin is the primary effector organ involved in temperature regulation. The loss or gain of heat occurs through the skin and can be modulated by activities in the skin. Our sweat glands produce a watery fluid that evaporates on the surface of the skin and takes lots of heat. We can also change blood flow to the skin to gain or reduce heat loss. The skin plays a role in communication. We assess people based upon their skin, their age, their happiness, their health, all sorts of things like that. The skin also is involved in vitamin D production, that in the presence of sunlight, you can produce vitamin D in your skin, and you can excrete small amounts of waste products. Okay, so let's talk about skin, and let me just remind you that there's these sweat glands that are associated with the skin. There's two types: the apocrine sweat glands, which release their materials into hair follicles, and that material is produced after puberty and is involved in communication between individuals. And then the eccrine or merocrine sweat glands, which release their material directly onto the surface of the skin. Okay, that's the glands we're talking about, these eccrine sweat glands, and they're releasing a watery fluid that's involved in temperature regulation. Okay, but the skin has much more than that when we talk about temperature regulation. Okay, the sensors, many of the sensors that are reporting back to the brain about skin temperature are located in the dermis. These things are particularly in the neck and the head, but all over the body are sending information to the brain, which is also getting information from the blood and blood vessels. The center in the brain that takes care of this is in the hypothalamus, and that hypothalamus contains the control center for temperature regulation. Likewise, the hypothalamus is also in charge of the pituitary gland, which controls metabolism, the rate we generate heat by controlling the thyroid glands and the thyroid hormones. Okay, and so the hypothalamus can change the rate that we lose heat by changing the activity of the sweat glands. When we are warmer than normal, the sweat glands become more active, the eccrine sweat glands, producing a watery material on the surface of the skin. That evaporates, and that takes a lot of heat with it. Okay, the hypothalamus can also affect blood vessels in the skin to change blood flow from near the surface to deep in the skin. It can change the activity of the erector pili muscles to make the hair stand up. And if we're really cold, it can turn up the activity of the skeletal muscles and the liver to generate more heat. Okay, I want to say a couple things about blood flow. When we are hot, when we want to get rid of some excess heat, we direct lots of flow of blood to the skin. And this increases heat loss, okay, because that warm blood is brought close to where it can radiate heat, and heat can be lost through convection, conduction, and radiation in addition to evaporation. When we're cold, we decrease the flow of blood to the skin and keep that blood deep in the body so it can keep the organs warm. And if we're cold, we can keep that blood flow not just away from the skin, but away from the arms and legs. And so our hands and feet can get cold, but that's happening to keep the rest of our body warm. Okay. What else do I want to say here? Oh, women versus men. Women are better at temperature regulation than men. Women have better control of their blood vessels, so they're more able to do this shunting of blood away from or to the skin. And they have more fat deposits in the skin than men, so they're better able to insulate their blood vessels. And so men are more likely to lose heat when they don't want to. Problems with temperature regulation can lead to hyperthermia, the body gaining too much heat and not being able to get rid of it, or hypothermia. These are severe problems that are involved in homeostasis. Okay, I wanted to say a little more about also about melanocytes and melanin and the transfer of pigment and things like that. So we all have about the same number of melanocytes, but some of us have melanocytes that are much more active. They're making melanin regularly, okay, and that melanin is being transferred to the keratinocytes so that the keratinocytes have more melanin all the time. Okay, and so some of us have darker skin than others. Okay, and this is a genetic factor that's more related to the where your ancestors came from. Okay, but all of us can produce more melanin when we need to. If we are exposed to UV light, that can induce melanocytes to produce more melanin. And so for some of us light-skinned people, we can tan, but even relatively dark-skinned people can get darker. This melanin is generally going to protect our cells. Most importantly, it'll protect the DNA of our cells from being damaged by UV light. And no matter where we are, we should think about limiting our exposure to ultraviolet light, sunlight. Midday exposures are the most damaging. That's when UV light is the strongest. And as we go farther and farther towards the tropics, UV levels get higher and higher. Sunscreens and sunblocks can effectively add to our protection by preventing UV light from penetrating deeper into the skin. When UV light does penetrate deep into the skin, what it does that's so damaging is it alters the structure of DNA. It causes the formation of these thymine dimers, where adjacent thymines become attached to one another, and this causes a kink in the DNA chain that has to be fixed. When DNA is damaged like this, we have mechanisms to fix it. However, those mechanisms sometimes fix it incorrectly. In general, our cells can take a lot of DNA damage. Most times if there's DNA damage, there's relatively little effect or no effect on the cells. But if it does affect an area that's made into a protein, that can cause an altered protein. And if that protein is critical, that may cause that cell to die. Even worse than having a cell die is that sometimes this happens to cells on the genes that control mitosis. And so those cells become what are called as transformed. They no longer have mitosis under control. They will become cancer cells. Okay, I want to talk about skin cancer, burns, and infections of the skin. So I'm going to go from there. This is just a picture here of kind of the way that you monitor your skin for melanomas, which is particularly look for moles that are changing, that become asymmetrical, that have irregular borders, that have color change, and then increase in diameter. But that's not the only type of skin cancer. There's 3 types of skin cancer. Basal cell carcinoma, the most common type, squamous cell carcinoma, and melanoma. The most common type, basal cell carcinoma, is fortunately the least severe. There are millions of cases of this every year. And this is due to chronic exposure, so it's often happening on the hands, the neck, parts of the face and ears, and maybe the shoulders. The good thing about basal carcinoma is it stays near the surface. If it spreads at all, it spreads on the surface, and it spreads slowly, so it can easily be removed with outpatient treatment. Another type of carcinoma, squamous cell carcinoma, is also due to chronic exposure. This is slightly more likely to spread, but still has good prognosis. Okay, the rarest but the most severe type of skin cancer is melanoma. Much less common, but it tends to occur in young adults after severe sunburns. It's more likely to spread, it metastasizes much more easily, and is much more often fatal than the first 2 types of cancers, but still has good prognosis. With early treatment, more than 80% of people are likely to survive, but it does produce about 8,000 deaths per year. With skin cancer, with skin cancer, early diagnosis is really important, leads to better outcomes. We need to monitor our skin and become aware of any changes. Surgery is the preferred option if caught early, just to remove it. But if we need to, we can kill cancer cells with radiation, chemotherapy, and immunotherapy. Of course, with all this, prevention is even more important than treatment. Okay, and that means limiting exposure to the sun and monitoring our skin, using things like sunscreens and sunblocks, or just covering up. Okay, another really important thing are burns. Burns are damage to the skin caused by heat or chemical exposure. Burns can be classified as 1st degree, 2nd degree, or 3rd degree burns. 1st degree burns are just involve the epidermis and will likely heal completely. And so that may lead to peeling and blistering a little bit, but if it's not too extensive, it's not bad. 2nd degree burns involve some of the dermis. 3rd degree burns involve all of the dermis and will not heal. With both 2nd and 3rd degree burns, there could be scarring, or there will be scarring, and if they're more than just small areas, they will require skin grafts. For burn patients, burns are very, very serious because of the loss of function of the skin. They're often followed by infections, difficulty in controlling water balance, and things like that. Okay, acne, onsets during puberty. There's lots of different kind of manifestations of acne depending upon the involvement. We go from individual whiteheads or blackheads, types of pimples, to cystic nodules, like you see here with this guy, where you have several things that are grouped together. Acne may cause scarring, and so you get the deposition of fibrous material in there. Treatment of acne is most effective if it's retinoids, but certain antibiotics, salicylic acid, these all work against bacteria, and then hormones that reduce the production of sebum and infection there. But acne is an infection of sebaceous and sweat glands. Okay, to summarize, skin functions to protect the body from infection, water loss, abrasion, and ultraviolet light. It produces vitamins when exposed to the sunlight, contains sensory cells, cells involved in pain, and skin is involved in communication. The skin is the primary effector of the negative feedback system that maintains temperature homeostasis. Okay, sweat glands can increase heat loss due to evaporative cooling. Changes in blood flow are important. Okay, damage to DNA from UV light can disrupt the cell cycle and lead to cancer. Melanomas arise from severe sunburns and pre-existing moles. Chronic exposure leads to basal cell and squamous cell cancers. Skin cancers are common but preventable.